Hello, good morning, students. I hope you all are fine. In the previous club, we have seen questions related to applied geotechnical engineering. I will continue with that. So the first question is, what do you mean by disturbed soil sample? So disturbed soil sample are the soil samples in which natural structure of the soil gets disturbed during sample. So as the name itself indicates, disturbed samples are nothing but samples in which natural structure of the soil gets disturbed during sampling. Next is area ratio. Define area ratio. So how we are defining area ratio? Maximum cross section area of the cutting edge to the area of soil sample into 100. Area ratio. So how we are defining area ratio? Area ratio क्या है? Maximum cross section area of cutting edge to the area of soil sample into 100. Next is AR, recovery ratio. D2 square minus D1 square divided by D1 square into 100. Area ratio is D2 square minus D1 square divided by D1 square into 100. Define undisturbed soil sample. Which type of soil sample is known as undisturbed soil sample? Undisturbed soil samples are the soil samples in which the natural structure of the soil and the water content are retained during sampling. So undisturbed soil sample क्या है? ऐसे soil samples in which the natural structure of the soil and the water content are retained during sampling. Define a recovery ratio. So what is recovery ratio? Recovery ratio is equal to length of sample recovered on sample tube. Recovery ratio क्या है? Length of sample recovered on sample tube to the total length of penetration of sample tube. Recovery ratio is nothing but length of sample recovered on sample tube to the total length of penetration of sample tube into 100. Define inside clearance. So how we are defining inside clearance? Inside clearance IP is equal to D3 minus D1 divided by D1 into 100. Similarly, outside clearance is equal to D2 minus D4 divided by D4 into 100. So how we are defining contact pressure? Contact pressure is defined as the vertical pressure at the surface of contact between the base of surface of footing and the underlaying of soil mass. Contact pressure क्या है? Contact pressure is defined as the vertical pressure at the surface of contact between the base of surface of footing and the underlaying of soil mass. So write an expression of computation of secondary consolidation settlement. So the secondary consolidation settlement is given by SS equal to CA into H into log to the base 10 TS minus TP by TP. So where H is the thickness of the clay layer, CA is the secondary compressed index. TS and TP are the time factor in seconds. Define stress isobar. So what is stress isobar? Stress isobar is a curve or contour connecting all points below the ground surface of equal vertical stress. So stress isobar क्या है? Stress isobar is a curve or contour connecting all points below the ground surface of equal stress. So next is expression for computation consolidation settlement. So the consolidation settlement is given by SP equal to U into SR, where U is degree of consolidation which varies from 0 to 100%. SR is the total or final consolidation settlement. Next is expression for computation of immediate settlement. So immediate settlement SI is given by SI equal to Q into B into 1 minus mu square into IF by ES, where Q is the intensity of contact pressure, B is the least lateral dimension of footing, mu is the Poisson's ratio, ES is the Young's modulus of elasticity of soil, IF equal to influence factor which depends on L by B ratio. State the different types of settlement of footing. The different types of settlement of footings are foundation settlement, next immediate or elastic settlement, primary consolidation settlement, secondary consolidation settlement. Module 3, define finite and infinite slope. So finite slope, if the slope is limited extent, then it is called as finite slope. So which type of slope we call finite slope? As a slope which is limit, if a slope is limit extent, then it is called a finite slope. Infinite slope. Any slope of rate extent is considered as infinite slope. Define active pressure. The minimum lateral earth pressure is known as your active pressure. क्या है एक्टिव प्रेशर? मिनिमम lateral earth pressure is known as your active pressure. Next, passive pressure. Maximum lateral earth pressure is known as passive pressure. State the drawbacks of Rankine's theory of earth pressure. The drawbacks of Rankine's theory are the back of wall is smooth, is far from truth. The resultant earth pressure always acts parallel to the surface of the backfill. So what are the assumptions made on finite and infinite slope? The assumptions made on finite and infinite slope are the failure for a earth slope occurs along a slip surface. The sliding wedges moves a rigid body. Next, define gross bearing capacity and net pressure intensity. So gross bearing capacity is the total pressure at the footing due to the weight of superstructure, self weight of the footing and weight of earth fill. So how we are defining gross bearing capacity? Gross bearing capacity is nothing but the total pressure at the footing due to weight of superstructure, self weight of the footing and weight of earth fill is known as your gross bearing capacity. Net pressure intensity Q1 is equal to Qn equal to Q minus sigma naught. The difference in intensity of gross pressure after construction of structure and original overburden pressure. Differentiate between ultimate bearing capacity and net ultimate bearing capacity. So the minimum gross pressure intensity at the base of foundation at which the soil falls in shear, that is net ultimate bearing capacity is equal to QNF equal to UF minus sigma naught. Define net safe bearing capacity and safe bearing capacity. So the net safe bearing capacity Qn is equal to QNF by F, where F is the factor of safety. Safe bearing capacity Qs equal to Qns plus sigma naught equal to Qns by F plus sigma naught. So list the different types of foundation. So the different types of foundation are shallow foundation and deep foundation. Next is differentiate between safe bearing pressure and allowable bearing pressure. Safe bearing pressure is the intensity of loading that will cause a permissible settlement or specified settlement for a structure. So what is safe bearing? Differential between safe bearing pressure and allowable bearing pressure. Safe bearing pressure is the intensity of loading that will cause a permissible settlement or specified settlement for a structure. Allowable bearing pressure is the net intensity of loading at which neither the soil fails in shear nor there is excessive settlement determined to the structure. So what do you mean by anchor piles? Anchor piles are used to encourage against horizontal pull from shearing, flying or other pulling forces. So what are the uses of compaction piles? Compaction piles are used to compact loose granular soil in order to increase the bearing capacity. What are end bearing piles? End bearing piles are used to transfer load through the pile tip to a suitable bearing stratum passing soft soil or water. So what are the uses of laterally loaded piles? The uses of laterally loaded piles are to support horizontal or inclined forces such as foundation of retaining walls, bridges and dams. So converse Labare formula. Neta g equal to 1 minus theta by 90 into m into n minus 1 plus n into m minus 1 divided by mn, where m is the number of rows, n is the number of piles in a row, theta is tan inverse of d by 3 degrees, d is the diameter of pile, s is the spacing of pile in the group. So define site investigation. What are the different objectives for which site investigation is done? Site investigation is done for obtaining information about subsurface condition and the size proposed construction objective. So what are the objectives of site investigation? To select type and depth of foundation, to locate the groundwater level, to determine the lateral earth pressure against retaining wall, to solve potential foundation problem, to investigate the safety of existing structure, to determine bearing capacity for a given structure. So these are the what you can say objectives of site investigation. Next is describe standard split spoon sampler with a net sketch. So this is the tip. वो भी उतनी चाहिए बना चल रहा हूँ। Standard split spoon sampler is used to open disturbed soil sample. It consists of mainly three parts. Number one, driving shoe, 75 mm long. Number two, split tube split longitudinally into two halves. Number three, coupling at the top of tube, 150 mm long. The inside diameter is 338 mm and outside diameter is 50 mm. The coupling has provided with check value and four venting parts 10 mm. To improve sample recovery, after the borehole has been made, the sampler is attached to the drilling rod and is lowered into the borehole. The sample is collected by forcing the sampler into the well tube repeated number of blows of drop hammer. The sampler is withdrawn and split tube is separated from coupling head and driving shoe and the sampler is taken up. It is then placed in contained seal and transported to the laboratory. Explain a rotary and percussion method of exploration and its suitability. Rotary drilling method. A borehole is advanced by rotating a hollow drill rod which has a cutting edge at its lower end. As the drill rod is rotated, the drill bit shear of the material penetrated. A drilling fluid under pressure is introduced through the drilling rod to the bottom of the hole. The fluid carries cuttings from bottom of the hole to the ground surface through annual space between the drilling rod and wall of hole. A rotary method used in clay, sand, and rocks. Percussion drilling method. This method is used for making holes in rocks, boulders, and other hard strata. A heavy chisel is alternatively lifted and dropped into a vertical hole. The material gets polarized. The point where the chisel strikes above water table, water is added to hole. The water forms slurry with polarized material which is removed by sand pump at regular interval. Module 2. Derive an expression or computation of consolidation settlement. The consolidation settlement at any instant of time can be expressed by SP equal to U into ST. So ST equal to total final consolidation settlement. U is degree of consolidation which varies from 0 to 100%. Coefficient of consolidation CV equal to TV into H into dr square by T. If U is less than equal to 60%, TV is equal to T by 4 into U by 100 square. U is greater than 60%, TV is equal to 1.7813 minus 0.9332 log to the base 10, 100 minus U. For single drainage, HDR is equal to H. For double drainage, HDR equal to H by T. Coefficient of compressibility AV equal to delta E by delta P. Coefficient of volume change MV equal to AV by 1 plus E naught. Coefficient of permeability K equal to CV MV gamma W. So your SP is equal to H into CC divided by 1 plus E naught log to the base 10 P2 by P1. CC equal to compression index E1 minus C2 log AP2 by P1. E naught equal to GS into WN. So CC is equal to 0.009 into LL minus 10, where LL is the liquid yield. Okay. A water tank is supported by a ring foundation having outer diameter of 10 meter and inner diameter of 7.5 meter. The ring foundation transmits a uniform pressure of 160 kilonewton per meter square. Compute the vertical induced at a depth of 4 meter below the center of ring foundation using Business analysis. एक वाटर टैंक है जो सपोर्टेड बाय रिंग फाउंडेशन हैविंग आउटर डायमीटर ऑफ 10 मीटर एंड इनर डायमीटर ऑफ 7.5 मीटर. तो एक वाटर टैंक है जो कि सपोर्टेड है रिंग फाउंडेशन पे हैविंग आउटर डायमीटर ऑफ 10 मीटर एंड इनर डायमीटर 7.5 मीटर. The ring foundation transmits a uniform pressure of 160 kilonewton per meter square. So you need to compute the vertical stress induced at a depth of 4 meter below the center of the ring foundation using Bousley's analysis. So R2 equal to 10 by 2, it comes out to be 5 meter. R1 is equal to 7.5 by 2, 3.75 meter. Q equal to 160 kilometer per square. And your Z is equal to 4 meter. So R1 is 3.75 meter, R2 is 5 meter. So sigma 2 into A is equal to Q into KV. So what are the assumptions made in the Rankine's theory and Coulomb's West theory? So Rankine's theory assumption: the soil mass is homogeneous, dry, cohesionless, and semi-infinite. So what is happening? The soil mass is homogeneous, dry, cohesionless, and semi-infinite, whereas the ground surface is a plane which may be horizontal or inclined. The backfill is vertical and small. The wall yields about the base and thus satisfies the condition of deformation for plastic deformation. So Coulomb's West theory assumptions: the backfill is dry, cohesionless, homogeneous, isotropic, and elastically undeformable but breakable. The slip surface is plane which passes through the heel of the wall. The sliding wedge acts as a rigid body. The position and direction of the resultant earth pressure are known. Explain the factors of safety using stability analysis. So factor of safety. No harm about. The factor of safety using stable analysis. So the factor of safety with respect to cohesion, assuming friction to be fully mobilized, Fc equal to C by Cm, or C equal to ultimate cohesion, Cm equal to mobilized cohesion. Factor of safety with respect to friction, assuming cohesion to be fully mobilized, F phi equal to tan phi by tan phi m, or tan gets cancelled is phi by phi m. Ultimate angle of shearing resistance, phi m is mobilized angle of shearing resistance. Factor of safety with respect to strength, F equal to TF by tau, or 2F equal to ultimate shear strength, and 2F equal to C plus tan phi, or 2 equal to mobilized shear strength, and 2 equal to Cm plus sigma tan phi. Factor of safety with respect to height is given by Fh equal to Hc by h, where h is critical height of slope, h is actual height of slope. Fh equal to Fc, assuming proven to be fully mobilized. Compare Coulomb's earth pressure theory or Rankin's earth pressure theory. Rankins theory: the soil is dry, cohesionless, homogeneous, and semi-infinite. And the back of the wall is vertical and smooth. The ground surface is plane surface which may be horizontal and inclined. The resultant of earth pressure is always parallel to the surface of backfill. Coulomb West theory: the soil is dry, homogeneous, and isotropic. The back of wall is rough and plane. The failure of surface is plane and friction is distributed uniformly on the failure surface. The position of resultant at pressure and position are known. So what are the assumptions, limitation of tertiary analysis? Assumption: the soil is homogeneous and isotropic. The strength of soil is represented by Coulomb's equation. The strip footing has a rough base and the problem is essentially two-dimensional. The elastic zone has straight boundaries inclined at phi psi equal to phi to the horizontal, and the plastic zones are fully developed. PP consists of three components which can be calculated separately and added. Failure zones do not extend above the horizontal plane through the base of the footing. So, what are the limitations? Trezeguet's theory is suitable for only shallow foundation. As the soil compresses, fall changes. Slight downward movement of footing may not develop fully the plastic zone. So, explain the different types of bearing capacity failures. There are three types of bearing capacity failures: general shear failure, local shear failure, punching shear failure. So general shear failure, it has well-defined failure surface reaching up to the ground surface. The failure is sudden with pronounced peak resistance and ultimate bearing capacities well defined. Local shear failure. The failure pattern is clearly defined only immediately below the footing and the failure surface do not reach the ground surface. The failure is not sudden and there is no lifting of footing and the ultimate bearing capacity is not well defined. Punching shear failure. No failure pattern is observed and the failure surface is vertical or slightly inclined, follows the perimeter of base. The failure is observed in terms of very large settlement and the ultimate bearing capacity is not well defined. Explain efficiency of pile growth. When closely spaced piles are grouped together, the soil pressure develops in the soil as resistance will overlap. The bearing capacity of a pile group may or may not be equal to the sum of the bearing capacity of individual piles in a group. A method of estimating the bearing capacity of piles of group fixes the quantity n given by a reduction factor called the efficiency of pile group. Q equal to neta g into n into Q or neta g equal to Qg by n into Q, where Qg equal to load carried by group of friction piles, Qf equal to load carried by each friction pile. N is the number of piles in the group. Now write a critical note on negative skin fraction. So negative skin fraction is a downward drag acting on a pile due to downward movement of the surrounding soil relative to the pile. This happened when the surrounding compressed soil has been recently filled up soil. As the soil consolidates, the earth moves downward, developing friction forces on the perimeter. As the soil consolidates, the earth fill moves downward, developing friction force on the perimeter of the pile, which tends to carry the pile further into the ground. The negative skin fracture may also develop by the lowering of the groundwater. Determination of magnitude of negative skin fraction. For cohesive soils, QNF equal to P into LF into C. For cohesionless soil, QNF equal to half into LF square into P into gamma into K into F. If P is the perimeter of pile, LF is the depth of fill in soil which is moving vertically downward. C is the cohesion of the soil in zone of LF. K is the coefficient of earth pressure. Gamma equal to unit weight of soil. F is the coefficient of friction equal to tan phi equal to tan pi. Alpha is equal to angle of friction equal to half pi to 2 pi 3 pi. Design a friction pile group to carry a total load of 4000 kilonewton at a site where the soil is clay up to a depth of 25 meter underlay by the rock. Take factor of safety as 3, cohesion equal to 80 kilonewton per meter square and check for group action. Assuming the diameter and length of the soil as 0.5 meter and 50 meter respectively, individual pile Q Cu NC into AB plus alpha Cu bar AS. Qu equal to 80 into 90 into pi by 4 into 0.5 square plus zero point 0.9 into 80 into pi into zero point 0.5 into 15. So your Qu equal to 1837.83 kilonewton. Qa equal to 183 1837.83 by 3 equal to 612.6 number of piles equal to 4000 divided by 612.61, so it comes out to be 6.529. So the revised length is 6.529 into 15 by 6, so it comes out to be 16.32 equal to 70 meters. Group fraction provide space as 2.5D, 2.5 into zero point 0.5, it comes out to 1.25. So the block failure QGN is equal to C into NCAG plus PGC bar L, where QGN is equal to 18 into 9 into 3 into 1.75 plus 2 into 1.75 plus 3 plus 80 into 17. So a QGN is equal to 5566.6 Newton greater than 4000 kilonewton. Hence it is safe. Section C.